Hi guys, I am back with my new video of pair of linear equations in two variables. It's a class 10th chapter number 3 in mathematics book. So here we go with our chapter. See, what we learnt in the previous class, first let us revise that. Okay, we learnt that x plus y. In 8th and 9th, we learned that x plus y minus 5 is a linear equation, or we can say it is an equation, right? But can we say that it is a linear equation? No, we cannot say it as a linear equation. Why we cannot say? Because a linear equation has a quadratic form. So, a quadratic form of linear equation is ax plus by plus c is equal to 0. Okay, if we write this situation in its quadratic form, so what will we get? X plus y, since we have 1x and 1y, plus 5 is equal to 0. Here we all know a is equal to 1, b is equal to again 1, c is equal to 5, right? Next we have the first topic of our class 10th, that the pair of linear equations graphically. How can we show them graphically? So we learn that pair of linear equations graphically. So we have three pair of linear equation on graph. First we have intersecting lines. We all know that intersecting lines will intersect at a single point. So here it implies that the two equations that will be having the intersecting lines, that will have a unique solution. Intersecting lines will have a unique solution. Okay, next we'll be having coinciding lines. Coincident or coinciding lines. In this we'll be having that one line is placed on the other line. These are the pair of solutions we have. We have our two equations. Let us take two. X plus y is equal to minus 5. The above we illustrate this example. 2x plus 2y is equal to minus 10. Here we will be having infinitely many solutions. That means the two equations will be having the same solutions. We learned how to make the solutions in the previous class, but we'll be revising that before doing our exercise 3.1. Okay, so in these two equations we'll be having infinitely many solutions, and most of the solutions they'll be having similar. Okay, that will imply them that the two equations are coincident, or they will be having coinciding lines or coincident lines. Okay, third pair of lines we have parallel lines. We all know that parallel lines are parallel to each other, right? So they will be having no common solution as they neither intersect or coincide, so they'll be having no similar solution. Unique solution, infinitely many solution, infinitely many solutions, and they will be having no solution, no solutions. So these are the 3 pair of lines that will be representing the linear equations graphically. Okay, now let us take our example number 1 of our NCERT textbook. We have that in section 3.1, let us see what is section 3.1. We have Akhila went to a fair in her village. She wanted to enjoy rides on the giant wheel and play hoopla. This is section 3.1. And play hoopla, a game in which you throw a ring on the items kept in a stall and the ring covers any object completely. You get it. The number of times she played hoopla is half the number of rides she had on the giant wheel. So let us illustrate the 2 equations or 2 solutions we'll be having. First statement, this is our example 1. First statement, we'll be having that the number of rides Akhila had bx. Okay, the number of rides Akhila had bx. Then the second second statement will be the number of times Akhila played hoopla. Played hoopla, by. In this, we have that the number of times she played hoopla is half the number of times she had on the giant wheel. That means y is equal to half of x. Number of times she played hoopla is half the number of rides she had. Okay, then we have further, the question implies that if each ride cost rupees 3 and a game of hoopla cost rupees 4, how would you find the number of rides she had and how many times she played hoopla provided she spent rupees 20? So we have our second equation, as this is our first equation. We have our second equation that 3x plus 4y is equal to 20. This is the prices of the game she had. Let us first solve our first equation. The first equation we have y 2y is equal to x. We'll be having this equation. If we write it in our quadratic form of equation, we'll get x minus x plus 2y plus 0 is equal to 0. We have 0 here, so no need to write it. We can simply write it as 0. So we will write it as 2y minus x is equal to 0. This is our first equation. And the second equation is a similar one. 3x plus 4y is equal to 20. This is our second equation. Now let us find the solutions for that. You have to find maximum 3 solutions of each and every equation. 3 maximum solutions. Okay, you can find more solutions than 10. you can find more solutions than 3 solutions, but the least solution or the minimum solution you can find out is the 3 solutions. Okay, so I prefer 3 solutions since you are going for board exams this year. So as we can use time less in solving these questions, we'll get as many time we can use in long solutions, long questions. We can use that time in long questions. So let us solve this using 3 solutions. We'll have the solutions that first let us put x and y here. One, 2 and 3. Okay, I prefer this way of solution. If you can do in this way, if you can do in this equation, you can find solutions in this way, you can do it. You are free to do it. Okay, no one is stopping you. I prefer this because it's the easiest way to find it. So 2y minus x will be having the solutions. Let we take x as 0. So 2y minus 0 is equal to 0. Right, 2y is equal to 0. Then y is also 0. So x is equal to 0, y is equal to 0. If we put x as 2, then minus 2 is equal to 0. 2 goes here, plus 2 upon 2, y is 1. 2 and 1. Then we put x as 4. X as 4. Then 4 goes here, we'll get 2. So these are the solutions for the first equation. Solutions for the first equation. Okay, now we'll find for the second equation. So the second equation, x, y, the solutions we'll be having. First, I prefer 0, so I'll be taking 0 here also. 0, 3 zeros are 0, 0 goes here, 20 and 4 cancel, we get 5. So first x as 0, y as 5. Then I prefer 4 here. 3 4s are 12. 20 minus 12, we get 8. 8 upon 4, we'll get 2. So 4 and 2. Then we'll take 8 here. So we'll get minus 1. 8 and minus 1. Okay. So these are the solutions we'll be having. And we had to find we just have to represent the statements algebraically and graphically. So graphically we'll be having the solutions. Okay, there's still 8. So 8 and 8. First equation, here we have 0, 0. We have the 0, 0. Then we have 2, 1. 2, 1, since 1 is here. then 2 comma 1 is here, okay, and 4 comma 2 will be having, let us take it here near the line, okay, then 0 comma 5, 0 comma 5, then again 4 comma 2, and then 8 comma minus 1. So when we'll make the lines, wait, let me make an again on each one. Okay, we can see here that the lines will meet at a point. This is 4 comma 2. Okay, then also I can make one on each one. So our first equation, as we know, is 0 comma 0, then 2 comma 1, then 4 comma 2, then we have 0 comma 5, 4 comma 2, and 8 comma minus 1. So when we cross check them, we'll get intersecting lines, and the unique solution is 4 comma 2. So it implies that the unique solution is 4 comma 2, and we get the intersecting pair of linear equations. Okay, let's move to our second example. The example states that Romila went to a stationery shop and purchased 2 pencils and 3 erasers. Let us write our first statement as, let the number of pencils be x, then let the number of pens be y. Okay, so first we have that Romila went to a stationery shop and bought 2 pencils and 3 erasers. So pencils we have as x, so first equation becomes 2x plus 3y for rupees 9, so is equal to 9. This becomes her first equation. Then her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils. She bought 4 pencils and 6 erasers of the same kind for rupees 18. You can see that we have the 2 equations as the similar. Both the equations are the same. How? If we take 2 common in this, we left with 2x plus 3y, right, is equal to 18. If we divide 18 by 2, we'll get 2x plus 3y is equal to 9. This is our second equation, which is similar to the first one. So let us now find out their solutions. What are their solutions? X and y. This is for the first one. First one was 2x plus 3y is equal to 9. So we all know that this will be having coinciding lines. How do we know this? That because both the 2 equations are similar. I told you that if the two equations are the similar, then they will be having the coinciding lines, or the lines which will be one over the another, right? And will be having infinitely many solutions. So x and y we get 0 if we kept as x, so we'll be getting 0 plus 3y, right? 0 plus 3y is equal to 9. Then y will become 3. If we keep 3 as x as 3, 2 3 are 6, we'll get 1 here. If we get 6, 2 6 are 12, 9 minus 12 will be minus 3, so we'll be getting minus 1. Okay, sorry, this is our minus 1. Okay, for the same this equation or this equation will be having the same solutions, so I'll not be finding the solutions for the second one. We have this as for the first and the second one both. So now let us make our graph. What is our graph? So we get 1. Okay, first solution we have 0, 3. Then we have 3, 1. Then we have 6, minus 1. That is, here we'll get it. Okay, so we'll be getting this as the second one also have the same solutions, so we'll be marking as like this, double 1. Okay, or you can find any other solution. Okay, this is a coinciding pair of lines. Now let us move to our example number 3. We have two rails are represented by the equations x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. Represent this situation geometrically. So the first, we are given the equations in this case we are given this equations, so we don't have to write the statement for this. Okay, if you do want to write this equation, you can just write that the first equation given is equal to this and the second equation given is equal to this. We are given these equations in the form of quadratic equation, right? But we don't want it in the standard form. We'll be finding the solutions in our normal form. We don't want the standard form of it. We'll be finding it in the linear equation form, not in the standard form of equations. Okay, so we will be writing our first equation as x plus 2y is equal to 4 and the second equation as 2x plus 4y is equal to 12. Okay, here our solutions become, wait, we can solve this second equation. We have this one, so we can solve this equation. X plus 2y is equal to 12. X plus 2y is equal to 6. Okay, this becomes our second equation. So let us find our solutions. Remember, in this case our solutions will not be same because the C given to us is different. Maybe A and B are the similar, but C is the different in this case. You have to check every situation for the coinciding lines. Okay, you can't just say that it is also a coinciding lines, since A1 is equal to A2 but C1 is not equal to C2. Okay, so X will be having Y, we'll get 0 plus 2y. 4 minus 0 is equal to 4. 4 upon 2 we get 2. Then we take 2 here. Then 2 plus 2y is equal to 4. We get 1. Then we take 4. 4 minus 4 is 0 and 0 upon 2 is also 0. So we take 4 and this as 0. This was for the first one. Next, for the second one we have X and Y. We'll be getting in this, let us take 0, then we'll get 3 here. We take 2, we'll get 2. We take 1, we'll get 4. Okay, so these are the two solutions. So let us make our graph. We have -1, -2, -3. 3, 4, -1, -2. We have x is equal to 0 and y is equal to 2. X is equal to 0 and y is equal to 2. 2, 1, 4, 0. The second equations we have 0, 3, 2, 2 and 1, 4 and 4, 1. So we'll have the pair of lines as this. We'll have no common solution in this form. Okay, so now we can see that we have all the 3 pair of lines that we want, or that are there for every solution. We have all the 3 pair of equations or 3 pair of lines. This is a parallel, this is coinciding, and the next one will this have the intersecting pair of equations. So now we start our exercise 3.1. The first question states that See, the first question states that Aftab tells his daughter, 7 years ago, I was 7 times as old as you were then. Also, 3 years from now, I shall be 3 times as old as you will be. Isn't this interesting? Yeah, it's very interesting. Represent this situation algebraically and graphically. Let us write our solutions or the statements for this first. We are given 7 years ago. We have Aftab's age as x plus x minus 7, it's ago, and daughter's age is equal to y minus 7 multiplied by 7, since her daughter is 7 times, right? Her daughter is 7 times younger than him, Aftab. So we'll have y minus 7 multiplied by 7. Her daughter is 7 times Aftab's age. Okay. So we get here 7y minus 49. Now we are given 3 years. So now we'll be writing of 3 years. So we'll write 3 years from now. 3 years from now. So it's in future. So we'll be writing Aftab's age as x plus 3 and daughter's age as y plus 3 multiplied by 3, since it's given 3 times, 3y plus 9. Okay. So now we have to find the solutions. First we have to put them equal. We have to make their that pair of standard form of equation. So we have 7 years ago, x minus 7 is equal to 7y minus 49. That means x minus 7y is equal to minus 42, right? So for this, our standard form become x minus 7y plus 42 is equal to 0, right? So this is our first equation. This one is our first equation. Then we have our second equation as x plus 3 is equal to 3y plus 9. So x minus 3y plus 3 minus 9 is equal to 0. X minus 3y minus 6 is equal to 0. This is our second equation. Now we'll get our solutions for this. Our solutions are follows. X and y we'll get, first I take 0, then 0 plus 42 is 0 only. 0 upon 7 give 0. Wait, actually 0 plus 42 will not be 0. 0 plus 42 will be 42. 42 goes here, it will become minus 42. Minus 42 upon minus 7, minus 6. Okay, 6. Then we'll have 7 and 7. 7 plus 42, 49. 49 upon 7, 7. I'm saying 49 upon 7. But this is because when we take 49 is here behind is equal to, we'll get minus 49, and minus 49 upon minus 7. It's given minus 7. It's not given positive 7, right? Plus 7. It's given minus 7. So minus 49 upon minus 7 will get plus 7. Okay. So here also we'll get plus 6. Then we have 14 and 8. You can take any other solution if you want. Any easier solution. I find it easy, so I'll be doing this only. Now comes our for second one. X minus 3y minus 6 is equal to 0. First we take 0. Then we'll get minus 2. If we take 6, then we'll get 0. And then 9, 1. Okay, now we'll make our graph. See, our graph follows like this. We have our first solution as 0, 6. 0, 6. Then we have 7, 7. 7. This goes here. Then we have 14, 8 here. Okay. Then we have 0, minus 2. 6, 0. And 9, 1. So we'll get the parallel lines. So our parallel lines goes like this somewhat. I'm not drawing it with scale. If you'll draw with its scale, then you'll get definitely the proper one. So let's now go for the next equation. Next question is as follows. The coach of the cricket team buys 3 bats and 6 balls for 3,900 rupees. So let us first write that first statement becomes cost of 1 bat be rupees X and cost of 1 ball be rupees Y. Okay, so we'll be having our first equation 3x plus 6y is equal to 3,900, and the second equation follows she buys another bat and 3 more balls of the same kind. Another bat means 1 bat and 3 more balls for 1,300. So these are the 2 equations we'll be getting, first and the second equation. Then let us solve it. First, if we solve this equation for first one, we'll get x plus 2y is equal to 3,900. How? Right? We get this? If we solve it further, we'll get x plus 2y is equal to 1,300. Right? So we have our 2 solutions, x and y. This is for the first one, and we'll be getting x as 1. So we'll be getting 700, 300, 900, 200. Am I right? 7, we get 3, 7, 21, 21 and 3, 6, 18. 21 and 18 we get 39, right? Then we have 9 and 900 and 200. 900 we get 2700 and 200 we get 27 plus 12, 3900. So if we next take 500 and 400, then we'll get 500 plus 400, 15 and 24. 15 and 24 we get 39. So the third solution we'll get 500 and 400. For the second equation we'll be having xy. First will be 100, 400. Then we'll take it as x as, if we take x as 200, then 1300 minus 200 we'll get 1100. Is 1100 divisible by 3? No. So we'll take here 700 and here 200. Then we'll take 400 and 300. Okay, so we'll have to solve it using graph. Now you all will be thinking how to make graph of 100, 400 and 700. So it's an easy task. We'll not take 1, 2, 3, 4. We'll take the intervals of 100, right? And till now we have taken the intervals of 1. But from now, in this case, we'll take intervals of 100. 100, 200, 300, like this till 1000. And then we'll make the graph. Okay, so our graph goes somewhat like this. We have our first equation as 700 comma 300. 1, 2, 3. Here we get our first solution. Then we have 900 and 200. 1, 2 we get our second, and 500 and 400. This is our third one. Okay, next we have 100 and 400, 700 and 200, 400 and 300. Let us make it. So this is our lines. We'll get intersecting pair of lines. You try it with scale, and on a graph you will get intersecting pair of lines. Okay, next we have last but not the least question number 3. We get the cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. After a month, the cost of 4 kg of apples and 2 kg of grapes is rupees 300. Represent the situation algebraically and geometrically. So our statements become let the cost of apples be rupees X, and let the cost of grapes be rupees Y. So we'll have the two solutions, two equations as 2x plus y is equal to 160 and 4x plus 2y is equal to 300. Second and first, when we solve it, we get 2x plus y is equal to 300. We will get 2x plus y is equal to 150. Okay, these are the two equations. The two solutions for the two equations we get. For the first one, x and y, we get 10 and 140. Okay, 20 and 120, and maybe we can take 1300. I think it will work. Let us check into it. Go for it. Okay. For second equation, we get x as 10, 130, 20, 110, and 30 and 90. These are for the two equations. Okay, the two solutions for the two equations. Next we'll solve it. We will have the graph. This is our graph, and let us go for our solutions. We get 10 and 140, then 20 and 120, and then 30 and 100. Then we have 10 and 130, 20 and 110, 30 and 90. Okay, you can see we get parallel lines. So these are the graphs, and this was the last but not the least question, and our exercise got finished here. Please like, share and subscribe my channel. Thank you so much for watching my video, and I'll meet you in the next lecture. Thank you.